This video lesson deals with the sine, cosine and tangent of angles from 0 degrees to 360 degrees. More specifically, the method for determining the sines, cosines and tangents of angles ranging from 0 degrees to 360 degrees. So the first thing we need to look at is the idea of a quadrant of a circle. A circle can be broken down into 4 quadrants. Each quadrant is simply a sector of a circle that subtends an angle of 90 degrees. So here's one quadrant. So a quadrant of a circle is essentially a quarter of a circle. Here's another quadrant, a sector which obtains an angle of 90 degrees, which can also be represented this way. Here's another quadrant, another quarter of the circle. So just roughly demarcating it, but as you can see, we have 4 quadrants here, 1, 2, 3 and 4. Each of these quadrants are quarters of circles. Quadrant, quarter of circle, so they're kind of related. And the key thing is a circle can be broken down into 4 quadrants. Now the convention we're going to use here is that this particular quadrant here to the top right is the first quadrant. The quadrant of the circle to the top left region is the second quadrant. The quadrant of the circle, which resides in the bottom left region, is the third quadrant, and the quadrant of the circle which lies in the bottom right region of the circle is the fourth quadrant. So we have the first quadrant, the second, third, fourth. So that's a convention. So anytime I refer to the first quadrant, I'm referring to this one here in blue. Anytime I'm referring to the second quadrant, I'm referring to the quadrant here in this region in gray here. Third quadrant is this one in brown, and the fourth quadrant, this region here in orange. As you know, if I start at a point and move along a circular path, I will cover an angle of 360 degrees. So this is a complete revolution, and the angle covered is 360 degrees. So a good way to show this is to start from this line. So this line, I've covered 0 degrees. As I move around, by the time I get to this point, I've covered an angle of 90 degrees. By the time I get to this point, I've covered an angle of 180 degrees. By the time I get to this point, I've covered an angle of 270 degrees. And by the time I get to the starting point, I've covered an angle of 360 degrees. So this is the idea of a revolution and just covering 360 degrees when you have a complete revolution about a point. But here, similarly, we are also considering the same idea, but we just need to point out the following, that angles between, so this is just the convention, angles between 0 degrees and 90 degrees lie in the first quadrant. So we start from this red line and I move. So line on this red line, I haven't covered any angle. So I've covered an angle of 0 degrees, which is nothing. As I move, I've covered a larger angle. So by this point, maybe I've covered an angle of, say, 30 degrees. As I continue to move, maybe at this point, maybe I've covered an angle of 60 degrees here, 60 degrees. As I continue to move, I'll get to this point where I have covered an angle of 90 degrees. So what I'm trying to say is angles ranging from 0 to 90 degrees lie in this quadrant. Because 30 degrees is something like this, 60 degrees is something like this, and an angle of 90 degrees is essentially this. But if I exceed 90 degrees, I'm in the second quadrant. And if, let's see, an angle like this, for instance, could be 120 degrees, for instance. By the time I come down all the way here, I'll have covered 180 degrees. So just to put it straight, angles ranging from 0 to 90 degrees lie in the first quadrant. Angles ranging from 90 to 180 degrees lie in the second quadrant. Angles ranging from 180 to 270 degrees lie in the third quadrant, and angles ranging from 270 degrees to 360 degrees lie in the fourth quadrant. And the main idea is as follows. We start from this red line here. At this point, we've covered no angle, so we've covered an angle of 0 degrees. We're moving along a circular path. As we move along, we're covering a larger and larger angle. So by this point, we might cover 30, 60, 90, 120, 180, 240, 270, 290, 320, 360. So that's the idea. We're moving along a circular path. We're covering an angle. We're moving about this point. We're covering angles. But what I'm trying to say is that as you move along that circular path, you will have covered an angle between 0 degrees to 90 degrees, you'll still be in the first quadrant. If you've covered an angle between 90 to 180, you'll be in the second quadrant. If you've covered an angle between 180 and 270 degrees, you'll be in this third quadrant. And if you've covered an angle between 270 and 360 degrees, you'll be somewhere on this arc of the fourth quadrant. So that's just the key thing here. So here on the left, you can see between the two red lines, an angle of 50 degrees is formed. This angle of 50 degrees lies between 0 degrees and 90 degrees, and as you can see clearly, it lies in the first quadrant. Whereas this angle here of 150 degrees, if you imagine starting from here, leads us to the second quadrant. 150 degrees lies between 90 and 180, so it's a second quadrant angle. Moving on, starting from here and moving along a circular path, as you can see, I end up in the third quadrant, this region here, when after covering an angle of 210 degrees. If you recall from this diagram, an angle of 210 degrees lies between 180 and 270, so it's in the third quadrant. And finally, we have an angle 300 degrees, so you might just start from here and moving along this circular path. By the time you've covered 300 degrees, you find yourself in the fourth quadrant. So these four diagrams here summarize what this diagram is saying and what these bullet points are saying. An angle between 0 degrees and 90 degrees lies in the first quadrant. Angles between 90 degrees and 180 degrees lie in the second quadrant. Angles between 180 degrees and 270 degrees lie in the third quadrant. Angles between 270 degrees and 360 degrees lie in the fourth quadrant. So that's a summary of everything so far. So the whole business of quadrant and angles which lie in certain quadrants was just an introduction to the theme of this video lesson. In this video lesson, we are trying to find the sines, cosines, and tangents of angles ranging from 0 to 360 degrees. So for instance, you might want to find the sine of 30 degrees. You might want to find the sine of 150 degrees. You might want to find the sine of 270 degrees. Now I'm going to give you techniques for determining the values of these expressions. In a video you'll see shortly, you see another method which involves the use of tables. But here we're using a special technique for finding the sines, cosines, and tangents of angles. So just observe. So for angles in the first quadrant, angles which lie between 0 and 90 degrees, with 90 degrees inclusive, the following holds. Now, the approach is as follows. If you need to find the sine or cosine or tangent of angle theta, all you need to do first is find a related angle alpha given by this formula. For angles in the first quadrant, the angle alpha is equal to the angle theta, and the sine of that angle theta is sine of alpha. The cosine of the angle theta is the cosine of angle alpha. The tangent of angle theta is the tangent of angle alpha. This is just an introduction, but for instance, say your angle was 30 degrees, theta was 30 degrees. The sine of theta is equal to the sine of alpha, according to this case. Now, what is alpha? Well, for angles in the first quadrant, alpha is equal to theta. So alpha is also equal to 30 degrees. So the sine of 30 degrees is equal to the sine of, what's alpha? 30 degrees. The cosine of 30 degrees will be the same thing as cosine of 30 degrees, because alpha is also 30 degrees in this first quadrant case. So for angles that lie in the first quadrant, there really isn't much to do. But when we move to angles in the second, third, and fourth quadrant, you'll see why all these formulas are useful. But just keep note in mind that for angles in the first quadrant, first of all, to determine the sines, you first determine a related angle alpha, where alpha is equal to the angle theta, which you're interested in. And the sine of that angle theta is the sine of the angle alpha. Cosine of theta is the cosine of alpha. Tangent of theta is tangent of alpha. All this will make sense when we do examples. But let's move on to procedures for determining the sine, cosines, and tangents of angles in the second quadrant. So now we're looking at angles in the second quadrant. We want to know how to determine the sine, cosine, and tangent of an angle in the second quadrant. So say the angle in the second quadrant is given by theta, i.e. the angle lies between 90 and 180 degrees. The angle theta must be less than or equal to 180 degrees for it to be in the second quadrant, but theta must be greater than 90 degrees, or 90 degrees must be less than theta. I mean, this is the same thing as saying theta is greater than 90 degrees. So for an angle in the second quadrant, it must be greater than 90 degrees, but less than or equal to 180 degrees. Now the key thing here, for example, an angle like 100 degrees. is a second quadrant angle because it is greater than 90 and is less than or equal to 180 degrees. Now, the procedure is to first determine an angle alpha, related angle. For an angle in the second quadrant, that angle alpha is given by 180 minus theta. So you just say 180 minus our angle, which we're interested in here, is 100, it's theta. So alpha, in this case, is 80 degrees, right? So if you were interested in finding the sine of 100, the cosine of 100, the tangent of 100, so the sine of 100 is equal to the sine of alpha, which is the sine of 80 degrees. This cosine of theta, which is 100, is equal to minus the cosine of alpha, which is 80. The tangent of theta is equal to minus the tangent of alpha. So tangent of 100 is equal to minus the tangent of alpha, which is 80 degrees. Now, all this may seem silly. I mean, why you're looking for the sine of 100? Why are you rewriting it as the sine of 80 degrees? Well, because this relation actually holds and is true. And in a lot of cases, it is easier to work this way. When you get to the examples, you'll see how useful this approach is. But the key thing to note is for angles in the second quadrant, so angles that are greater than 90 degrees, but less than or equal to 180 degrees, you have to find a related angle alpha, which is given by 180 by theta. So theta was your angle in the second quadrant. And the sine of that angle theta is given by sine of alpha. The cosine of the angle theta is given by minus the cosine of alpha. The tangent of that angle theta is equal to minus the tangent of alpha, that related angle we found. When we get to the examples, this will all make perfect sense. But just keep this in mind. I'm just introducing you to the main idea you're going to use to solve the questions on this topic. For angles in the third quadrant, so for example, an angle theta, in this case, is what we refer to as a third quadrant angle. An angle in the third quadrant is less than or equal to 270 degrees, but is greater than 180 degrees. So 180 degrees is less than theta. It's the same thing as theta is greater than 180 degrees. When you have an inequality, if you swap the left hand side and right hand side terms, you have to reverse the symbol. And doing so gives theta is greater than 180 degrees. So an angle in the third quadrant is greater than 180 degrees, but it's less than or equal to 270 degrees. So an example will be 240 degrees. An example will also be 270 degrees, because 270 degrees is less than or equal to 270 degrees. So it's actually equal to 270 degrees. So these are examples of third quadrant angles. Now, when you want to determine the sine, cosine, or tangent of a third quadrant angle. So by the way, theta is what we use to refer to a third quadrant angle in this case. Yeah, you need to find first a related angle alpha, which is given by theta minus 180 degrees. So when theta is 240 degrees, 240 degrees is a third quadrant angle. The related angle alpha is going to be given by theta minus 180. 240 minus 180 is 60 degrees. Now, the sine of the angle we're interested in, theta, sine of 240 degrees, is given by sine theta is equal to minus sine alpha. So it's equal to minus sine alpha is what? 60 degrees. The cosine of theta, the angle we're interested in, cosine of 240 degrees, is given by minus the cosine of alpha, which is 60 degrees. The tangent of theta, tan of 240, is equal to the tangent of alpha, which in our case is 60 degrees. Now, if you recall, there's a previous video which covers common trigonometric ratios. And in that video, we looked at the sine, cosine, and tangent of 30 degrees, 60 degrees, and 45. And in that video, basically gave you the technique for determining the sines, cosine, and tangents of 60 degrees, which is something you should know now by heart. So when you want to find the sine of 240 degrees, because you already know what the sine of 60 degrees is, you can easily work it out. For instance, you want to determine the cosine of 240 degrees, you just know that, well, that's equal to minus the cosine of 60 degrees. When we learned from that video, we know that the cosine of 60 degrees is simply 0.5. So that means the cosine of 240 degrees is equal to minus the cosine of 60 degrees, which is 0.5. It's that simple. So this technique actually saves you a lot of time and stress, and you will see its usefulness when you get to the examples. So now for angles in the fourth quadrant, so I'm going to use theta to represent a fourth quadrant angle. Angles in the fourth quadrant are less than or equal to 360 degrees and are greater than 270 degrees. An example of a fourth quadrant angle is 300 degrees. Another example is 330 degrees. Another example is 360 degrees. All these angles are greater than 270 degrees, but less than or equal to 360 degrees. Now, to determine the sine, cosine, and tangent of a fourth quadrant angle, so to find sine theta, cos theta, and tan theta, the first thing you need to do is find a related angle alpha, which is given by 360 minus theta. So for fourth quadrant angles, the related angle alpha is 360 minus theta. So when theta is 300, alpha is going to be 360 minus 300. Alpha is going to be 60 degrees when theta is 300 degrees. So if you wanted to find the sine of theta, so the sine of 300 degrees, you simply have sine of 300 degrees is equal to minus sine alpha, which is 60. The cosine of theta, 300 degrees, is simply the cosine of 60. That means the cosine of 300 degrees is simply 0.5 because the cosine of 60 is 0.5. The tangent of theta, tangent of 300 degrees, is equal to minus the tangent of alpha minus the tangent of 60 degrees. So the key thing here is the following. We looked at angles in the first, second, third, and fourth quadrant, and we looked at the procedure for determining their sines, cosines, and tangents. Now, the things you need to remember for each quadrant, or for an angle in each quadrant, is that you need to know the formula for alpha. For an angle in fourth quadrant, alpha is 360 minus theta. And the sine of theta is minus sine of alpha. The cosine of theta is equal to cosine of alpha. The tangent of theta is equal to minus tangent of alpha. So equations A, B, and C. Now you need to remember these equations and this formula as well for each quadrant because they vary. And I'm going to show you an easy way to remember them. You don't have to cram all the formulas for each quadrant. That will be extremely difficult. But there's a technique, or there's rather an approach for remembering these formulas without any hassle. And I'm going to show you that next. So here I have a circle, and I've divided it into 4 quadrants. The first one, the second quadrant, the third quadrant, and the fourth quadrant. And as you can see, I've labeled each quadrant with a letter of the alphabet. Here we have A, S, T, and C. So an easy way to remember this is to just pronounce it in this fashion. So C-A-S-T, cast. So you need to remember the acronym CAST. Or C-A-S-T. C here stands for cosine. A stands for all. S stands for sine. T stands for tangent. But what does all this mean? How is this useful? Well, now for angles in each quadrant, remember to determine their sine, cosine, and tangent, we first had to find a related angle alpha. And there was a formula for that related angle. But the base form of all those equations is this. You always had sine theta is equal to sine alpha, cos theta is equal to cos alpha, tan theta is equal to tan alpha, but with some modification. And I'm going to show you the modifications. Now, for a first quadrant angle, so angles in first quadrant where we have A, all the equations have positive signs in front of all the equations involving alpha, or all the expressions involving alpha, so like sine alpha, cos alpha, and tangent, have positive signs in front of them. So sine theta is equal to plus sine alpha, cos theta is equal to plus cos alpha, tan theta is equal to plus tan alpha. So what this A is saying, this all is saying that all these equations, in all the equations involving alpha, there's a plus sign in front of the expression, like the trigonometric function involving alpha. So in front of sine alpha we have a plus, in front of the cosine of alpha we have a plus sign, and in front of the tangent of alpha we have a plus sign. In maths, you know you don't have to show plus signs, so I'm just going to drop them. So essentially, for angles in the first quadrant, sine theta is equal to sine alpha, cos theta is equal to cos alpha, and tan theta is equal to the tangent of alpha. Now, for an angle in the second quadrant, we have this S here, and this S here refers to sine, and it's saying that it's only the expression involving the sine of alpha that has a positive sign in front of it. For the other expressions, you have a negative involving alpha, you have a negative sign in front of the trigonometric function. So if you look at all the expressions here, all the trigonometric functions involving alpha here, sine alpha, cos alpha, and tan alpha, we essentially have a plus sign in front of them. For an angle in the second quadrant, only the sine alpha has a plus sign in front of it. All the other trigonometric functions like cos alpha and tangent of alpha have a negative sign in front of them. It's going to make sense at the end. For a third quadrant angle, so in third quadrant we have t here, representing tangent, saying that it's only in front of, from this base form, only tan alpha has a positive sign in front of it. That means sine theta, I mean, if you think about it, let's write the base form. Sine theta is equal to sine alpha, cos theta is equal to cos alpha, and the tangent of theta is equal to the tangent of alpha. Now, for a third quadrant angle, only tangent alpha has a positive sign in front of it. The cosine and sine of alpha have negative sign in front of them. Let's deduce the formula for fourth quadrant angles. So we write the base form first. So sine theta is equal to sine alpha, cos theta is equal to cos alpha, and tan theta is equal to the tangent of alpha. Now for an angle in fourth quadrant, we have C here. And C means that only the cosine of alpha has a positive sign in front of it. The sine of alpha has a negative sign in front of it, and the tangent of alpha has a negative sign in front of it. So I'm just going to summarize. For the equations relating the sine of theta to sine of alpha, cos of theta to cos of alpha, for angles in each of different quadrants are given here. And the way to remember them is first to remember this base form, which is just easy to remember. You just have sine theta is sine alpha, cos theta is cos alpha, tan theta is tan alpha. We just have this base form. So you have the base form, and then you look at this diagram here, cast. In the first quadrant angles, you have an A. And this A means all the trig functions involving alpha have positive signs in front of them. For a second quadrant angle, only sine alpha has a positive sign in front of it. Cos the cosine of alpha and the tangent of alpha in this base form have negative signs in front of them. For third quadrant angles, you have the base form, but only the tangent of alpha has a positive sign in front of it. The cosine and sine of alpha have negative signs in front of them. For the fourth quadrant, you have the base form, but only the cosine of alpha, C for cosine, has a positive sign in front of it. The sine of alpha and the tangent of alpha have negative signs in front of it. So that's an easy way to remember the formula. In essence, all you have to remember is this base form, which is easy to remember. And you just need to remember cast and the positions of C, A, S, and T. And you just need to know that C means cosine, A means all, S means sine, T means tangent. And they all refer to which trigonometric functions have positive signs in front of them, and the trigonometric functions involving alpha. So remembering this base form, remembering this diagram, and this allows you to deduce all these formulas. And we're going to use them in examples, so it's going to make sense at the end. But just take note of this so that you can remember it being mentioned when it's being used in the solutions to the example questions.